Hi there, back for more exponent rules. Today we're going to be looking at lesson 7.4. We're going to look at two exponent rules. One is called power to a power, and the other one is called product to a power. Now remember, the goal of the exponent rules is to be able to take an expression and simplify it using the exponent rules. So these two exponent rules have to do with multiplication. What we'll do is we'll take a look at each one individually. I'm going to write this out and expand it, and then what I want you to do is to see if you can come up with a rule that will be much quicker instead of having to write it out every single time. So let's first look at power to a power. We see here that we have 4 to the 5th power, and we're going to raise that to the 2nd power. So we have a power raised to another power. That's where it gets its name from, power to a power. So I'm going to rewrite this, 4 to the 5th power to the 2nd power, which means I want to take 4 to the 5th power and multiply it by 4 to the 5th power, twice, because the exponent says 2. Now we know that if we take two powers and we multiply them together, if they have the same base, we can just add the exponents. So you should know that this would be 4 to the 10th power. But I could write it out. 4 to the 5th power would look like this. And then if I multiply it by another 4 to the 5th power, you can see here that there are 10 4s. So that is the same as 4 to the 10th power. Now let's look at the next one. Here we have n to the 2nd power, and we're going to raise that up to the 3rd power. Again, power to a power. So n to the 2nd power, we're going to take this to the 3rd power, so we're going to have to multiply it by itself 3 times. Now again, you know that if you're multiplying powers that have the same base, you just add the exponents, 2, 4, 6. But if I were to write it out, n times n, times n times n, times n times n. Of course, there's 6 of them. Now what I'd like you to do is to see if you can notice a quicker way to do this. So if I have a power and I raise it to another power, what could you do with the exponents to get your answer? Does it work here? Do you see it? Of course, you want to multiply. If you have power to a power, you can multiply the powers, and of course, the base stays the same. Here the n, right? Okay, let's go down here to the rule. To raise a power to a power, multiply the powers. And the base stays the same. Perfect. Now let's take a look at the next one. Here we have product to a power. Now this is called product to a power because when you take two numbers, these would be called factors. When you take two factors and you multiply them together, it becomes a product. We're going to take the entire product of 3x and raise it to the 2nd power. Now I'm going to expand this. Write it out. 3x to the 2nd power is the same as 3x times 3x. Now I'd like you to notice here that the 3 times 3 could be written as 3 squared. And the x times x could be written as x squared. Now do you notice here that the 3 and the x, because they were both in the parentheses, they both had to be raised to the 2nd power. The 3 is to the 2nd power, and so is the x. Now in this case, I could simplify. We know that 3 squared is 9. And this would be my final answer. But I really wanted you to see that both numbers inside the parentheses, both factors, did have to get raised up to the 2nd power. Let's see what happens in this one. ab to the 3rd power. A and b are both factors. Together they make a product. Let's raise it to this power. ab times AB times AB would be AB to the 3rd power. Now if you take a look and see what we have here, A times A times A would be A to the 3rd power. And B times B times B would be B to the 3rd power as well. Now if you notice, both of the factors had to get raised to the 3rd power. They were both in the parentheses, and everything in the parentheses has to come up to the 3rd power. This is called product to a power. Let's take a look and see how we can write this rule. To raise a product to a power. Well, what did we do? We had to raise each factor up to that power, didn't we? Raise each factor to the power, and in some cases, like this one right here, we had to simplify. All right, these are our two new exponent rules. Let's see if we can apply them. So let's take a look at example number 1. We have this expression, and everything inside of the parentheses is being raised up to the second power. So this is an example of product to a power. Each factor, the -6, the p, and the q, all are going to have to get raised up to the second power, each one individually. Now we have some multiple choices we can choose from here. Let's try this. If I take -6 to the second power, that's -6 times -6, which you know is 36. Right now we can say that it can't be a or c. Now let's try the p. P has to be raised up to the second power, but do you notice that it already has a power? So I'm going to be taking something with a power and raising it to another power. Power to a power, multiply the powers. Now let's try Q. But Q already has a power, and I want to raise it to another power. Power to a power, multiply the powers. And there we have it. Here's our expression in simplified form. And it looks like that matches up with answer B. And there we go. Let's try number 2. Looks like we have these two h's being multiplied together. But hold on. This one can be simplified. Here I have a power raised to another power. Power to a power, multiply the powers. Now let's bring everything down in the front. Okay, now it looks like I have powers that I'm multiplying together, and they have the same base. When I multiply powers with the same base, I add the exponents. -2 plus -12 is -14. But you know that you can't leave a negative exponent. So I'm going to make it a fraction, so I can see that this is going to have to go downstairs. The base stays the same, the exponent becomes positive, and of course we have a 1 in the numerator. So we started with this expression, and we were able to simplify it all the way down to this one, 1 over h to the 14th. Now number 3 and 4 are very similar. I'll walk you through number 3, and then I'd like you to try and see if you can pause the video and try 4 on your own. Let's look at 3. Do you see the n? It's raised to the 5th power, but I'm going to ask you to raise it to another power, to square it right here. Power to a power, multiply the powers. This would be n to the 10th. Now let's see what we have in here. All of this inside the parentheses has to be raised up to the 3rd power. Each factor goes up to the 3rd power. The 4 shoots up to the 3rd power, the m, and the n. 4 to the 3rd power, the m up to the 3rd power, and the n up to the 3rd power. However, do you notice that the n already has a power, and I want to raise it to another power? So power to a power, multiply the powers, -6. Now, I notice here that I have an n and another n, and I can combine them. When I'm multiplying powers with the same base, I want to add the exponents. So 10 plus -6 is 4. I also know that 4 times 4 times 4 is 64. And then I'm just going to bring down my m. No negative exponents. I think we have this simplified. Now, pause the video, and I'd like you to try number 4. It's very similar to number 3. Then you can play the video and see if you have it right. All right, let's give it a try. Here, again, power to a power. Multiply the powers. Now, both of these factors inside the parentheses have to shoot up to the -2nd power. So 2 to the -2nd power. Remember, you can't evaluate that yet because it's a negative exponent, so just write it down. Now the r. The r already has a power, and I'm raising it to another power. So power to a power, multiply the powers, +10. Now you'll notice here that there's a couple negative exponents. You're going to want to write a fraction so that you can see that these negative exponents are going to have to go downstairs. The only thing that stays in the numerator is r to the 10th. So the s is going to move downstairs and have a +12th exponent. Now the 2 to the -2nd power will move downstairs and become 2 to the +2nd power. And you know that 2 squared is just 4. So it looks like this is my simplified answer. I started with this expression and I end up with this one. Everything has positive exponents. All right, let's take a look at number 5. Do you notice in this first part here, everything in the parentheses isn't going to be raised to any other power. We really don't have anything to do with this part. We could just copy it down again here. We know it's being multiplied together. But over here, inside this set of parentheses, everything's being raised to the negative fourth power. I am going to have to simplify here. Both factors are going to have to shoot up to the negative fourth power. So I have 2 to the negative fourth power. Remember, you can't evaluate that yet. You have to just write it down. It has a negative exponent. Now the a. The a already has a power. So power to a power, I multiply the powers. Positive 12. Now let's look and take a peek and see what we have. I notice a to the second and a to the 12th. When I multiply powers to the same base, I add the exponents. So that's going to be a to the 14th.
Dad, I shot somebody so much.
Okay, then I have the negative 4. I'm just going to bring that down. It has a positive exponent here. And then I also have this one. Let's bring this down. 2 to the negative 4th. Now I just combined the a's. That's all I did to get a to the 14th. Now I'm going to take a look and see what I have, and I notice a negative exponent. So I'm going to write a fraction. This is going to have to come downstairs. So negative 4, remember it has a positive 1 exponent, that's why it stays there. And a to the 14th, all over, this one's coming down. It's going to come down here and become 2 to the positive 4th. And you know that 2 times 2 times 2 times 2 is 16. So I'm going to put 16 down here. But then you will notice that this fraction, negative 4/16, that can be simplified. You can divide by 4, top and bottom, right? So really this is negative 1 over 4. A to the 14th stays up top. I really wouldn't need to put the 1, but I can leave it. And here's my simplified answer, right here. So I started with this expression and simplified it all the way to this right here. All right, let's try 6. Looks like everything's in parentheses and all of it's being brought up to the negative second power. All 3 of these factors in the parentheses have to shoot up to the negative second power. 4 goes to the negative second power. M goes up to the negative second power, and so does the n. All right, let's write this down. 4 to the negative second. Remember, you can't evaluate that yet. There's a negative exponent. M is going to shoot up to the negative second power. It already has a power. So power to a power, we multiply the powers. And I get m to the positive 8. Now n. N already has a power, and I'm raising it to another power. So power to a power, I multiply the powers. Now let's take a look and see what we have. Nothing to combine, but I do notice negative exponents. So go ahead and make a fraction right away. Then you'll notice that these are going to have to come downstairs. The only thing that stays in the numerator is m to the 8th. Now 4 to the negative second comes downstairs and becomes 4 to the positive second, and you know that that's 16. The n's going to come down and join it, only now that the n's downstairs, it will have a positive exponent. And there's my simplified answer. All right, number 7. Wow, look at this one. Well, let's take a look at what we have. Everything inside this set of parentheses, all 3 of these factors, we're going to have to raise them up to the negative second power. This one goes up, this one, and this one. But take a look over here. Everything in this set of parentheses is going to go up to the 4th power. All 3 of these factors, up to the 4th, every one of them. We have a lot of simplifying to do. Let's just take a look and write everything out for what we have. 3 up to the negative second power. Write it out. You can't evaluate it yet. It has a negative exponent. M, we're going to bring that up to this power. But do you notice m already has a power? So power to a power, I multiply the powers. N, it already has a power, and I'm raising it to another power. Power to a power, I multiply the powers. Okay. Let's see what we have here. 2 up to the 4th power. M already has a power, and I'm raising it to another power. Power to a power, multiply the powers. N, it already has a power, and I'm raising it to another power. Power to a power, I multiply the powers. Wow, there we go. Now let's look and see what we have. I can't combine these 2. This one has a negative exponent, this one doesn't, so leave them. But do you notice the m? I can combine the m's. When I multiply powers with the same base, I add the exponents. 2 and 12, 14. Okay, let's do the n's. When I multiply powers with the same base, again, I add the exponents. -8 plus -20. Okay, now I have 2 to the 4th. And then I have 3 to the -2nd. Okay, I notice I have 2 negative exponents. So at this point, you see, I just brought this down and I just brought this down. Okay, now I have 2 negative exponents here and here. I'm going to need to create a fraction because the negative exponents are going to have to come downstairs. So let's see what stays up top. 2 to the 4th gets to stay, and we know that that's 16. M stays. Now, 3 to the -2nd is going to have to come downstairs. It will become 3 to the +2nd, which is 9. N has to come downstairs too. When it comes down, the exponent will become positive. I don't think we can simplify 16/9, so this looks like our final answer. Not bad. We started with all of this, and we end up completely simplified down here. All right, number 8. This is asking which expression represents the area of the square. We've done one like this before. We know that a square has the same length sides. So if this is 4x to the 5th, this is 4x to the 5th. And we know that to find the area, we take length times width. So we would have to multiply both of these together. Go ahead and try it. Pause the video. See if you get the right answer. All right, so if I multiply these together, I have 4x to the 5th times 4x to the 5th. I know that I can take 4 times 4 and get 16. So it can't be A or B. Now, x to the 5th times x to the 5th. Remember, when I multiply powers with the same base, I add the exponents. So this would be x to the 10th. Remember, if I expanded this out, this would be 5x's, and this would be 5x's, making 10. So the area is 16x to the 10th. Did you get it right? I hope so. All right, let's take a look at number 9. Number 9 says that the area of the rectangle is 36x to the 8th, y to the 7th. It's this expression right here. We're asked to find the width of the rectangle. So right here you can see this is the width, and here we have the length. And we know to find the area of a rectangle, we take the width times the length, and that will give us the area. But we don't know this width. So if I write this out, I can say that the width, which is unknown, times the length, which is right here, equals the area. And what I'm trying to find is this missing width. So what's the width? What do you see? What number multiplied by 9 gives us 36? Well, that would be 4. Now I need the variables. Let's look at x. Now our goal is to get x to the 8th. Here I have x to the 3rd. If I'm multiplying powers with the same base, I have to add the exponents. So what plus 3 equals 8? You've got it, 5. Do you see here how if I add the exponents, I get 8? Now let's look at the y. This is y to the 4th, and we have to multiply it by something to give us y to the 7th. Again, if I'm multiplying powers with the same base, I have to add the exponents. So what plus 4 would give you 7? You've got it, 3. So here I found the width. The width is 4x to the 5th, y to the 3rd. So if I would take the width times the length, I would have the area. Now number 10 is very similar to number 9. Maybe you want to try and pause the video and see if you can figure it out first. Then you can play the video and see if your answer is right. Here it says the area of the rectangle is 40n to the 16th. And we're asked for the length this time. That's this part right here. How long is this? Again, you know that the length times the width equals the area. So length times the width, which is this 5 n to the second, equals the area. All right, well, let's look at the numbers. What number times 5 will give us 40? Well, it'd be 8. They're all 8. Now let's do the variable. Now remember, when we're multiplying powers with the same base, we add the exponents. So these two exponents would need to be added together to give us n to the 16th. What would this one have to be? You're right, 14. Then if we added them, we'd get 16. So, looks like the length would have to be 8 n to the 14th. Did you get it right? It would be C. Very good. And that's all I have for you today. That's lesson 7-4. Have a good day.